Hello everyone, thanks for your time. In this research project on applying a technology to solve a real world problem, we examine the application of IoT based technologies in the field of healthcare. So, what in the name of technology is IoT? IoT stands for Internet of Things. It is a term first attributed to Kevin Ashton in 1999 when he was working on a project at Procter& Gamble. He used the term to refer to RFID building gadgets which would be connected together to form a network. Since that limited origin of the term, IoT has expanded in scope. There are many different definitions to IoT floating around in the technological ether. The one that we found the most simple and explanatory goes like this: sensors and actuators embedded in physical objects are linked through wired and wireless networks. So, why did the industry need to come up with a term to describe this interconnection of gadgetry things? The reason is that the computing model and the use case for IoT is a bit different from previous models. In these other models, a human initiates an action by typing something or clicking on something. Then the computer does some processing and shows the result back to the human user. In IoT, however, a sensor gadget takes a reading. It sends it out to the data collector. Then the analytical engine acts on it to generate an interpretation of that reading and then forwards the message to another sensor that takes action. All of this happens without human intervention. In other words, let's take the example of a home security system. Please note that this is the description of how a hypothetical system works. The actuals of various commercial systems will vary. So, when a motion sensor detects movement, it sends that information to a hub that relays the start recording command to a linked set of cameras that comply and start filming. The images or video clips captured are sent to the hub, which then compiles a notification message and sends it to a phone number or email ID. Now, let's take a look at the same use case from a bit more technical perspective. Let's talk about connectivity first. The local hub and the devices are constantly connected to each other. The hub continuously pings the individual devices to make sure they are healthy. The hub may or may not be constantly connected to the service's remote gateway, which might be in the cloud. So, in this use case, the communication between the sensors, hub, and cameras is completely local. When the hub gets the images and videos from the cameras, it uploads them to the service's inbound gateway. The gateway then stores all that data in a distributed data store and triggers the processing pipeline to pick it up and run the necessary rules on it. The rules can be as simple as directly notifying the user with pictures and videos attached, or it can be as complicated as running machine learning algorithms to try and match the intruder, or if he is carrying a package to deliver, or it's simply a kid trying to retrieve a football that made it into the user's property. Then, based on this information, either generate a low severity notification to the user or raise an immediate alarm. Now, let's talk about categorizing different IoT systems. IoT systems can be categorized in multiple ways: the technology involved, the frequency of capturing data, the type of data captured, whether the analysis has to be done in real time or as an offline batch. We believe that the density of data and the number of end devices involved are a fundamental criteria. The density of data determines the bandwidth of the data processing systems, whereas the number of end devices determines the multiplicity needed to serve that use case. Once these values are known, the technologies needed and the SLAs that can be met can be derived. So, based on these two criteria, as we see here, there can be good IoT systems that are either good at processing dense data or are good at handling a large number of end devices. A good example of dense data application is industrial IoT. An aircraft engine generates megabytes of sensory data every minute. The data is not just numbers, but waveforms. On the other hand, consumer IoT applications typically have millions of devices intermittently sending data. It's not worth talking about systems that are data sparse and device sparse. On the other hand, Most use cases will eventually find themselves being pushed to the lower right corner, and that's where the problems arise. As with most things in life, there's always a trade off. It's anywhere from cost prohibitive to practically impossible to build a system that can process all the data we throw at it in real time. So, the designer's skill is to break down the system into two or more subsystems that are individually excellent at addressing one use case rather than being unreliable trying to solve all the problems. Understanding strengths and weaknesses of big data based IoT solutions is going to help us understand appropriate applications of the technology. As we shall see, the biggest strength of IoT is the capability of gathering data from any kind of sensory gadgets.
Hi, I'm Anamika. I'm going to talk about the current implementation of IoT in healthcare. Already, there is a lot of IoT-enabled healthcare products in the market. For this presentation, we will be discussing 6 different categories of products that are truly revolutionizing our lives. These different categories are: first, continuous glucose monitoring system; second, carving sensor; third, wearable devices; fourth, ingestible sensors; fifth, IoT enabled inhalers; sixth, blind assistants. Let's start with CGM, also known as Continuous Glucose Monitoring System. As part of this system, an IoT-enabled sensor is placed under the inner layer of skin and a transmitter on the outer layer. The sensor monitors the glucose level and sends the data via the transmitter to any web or mobile application. User or patient can pre-set up alerts which would notify responsible stakeholders such as emergency contact, doctors, nurses, etc. The system is already proving helpful to diabetic patients and also improving A1C level. Now let's move on to the next category, that is calving sensor. This calving sensor is an IoT device which is used mostly by cattlemen and ranchers. A calving sensor has been developed by a company named Moo which places its sensor on the tail of birthing mothers as shown in the images. These sensors send an alert in case of high activity via an application. This sensor has reduced the mortality rates for cows and calves, helping in increasing the productivity of ranchers by saving time and resources in managing the cattle. Now, moving on to the next category, which is wearable devices. Most companies like Samsung, Apple, Fitbit, etc. have already made an impact in providing the best product to the consumer. These devices monitor blood pressure, heart rate, calories burned, steps taken, etc., which gives the user complete knowledge of his day-to-day activities and manage their health. There is another very specific wearable product on market called IT Bra, which is helping a lot of women by providing an early detection of breast cancer. This provides the patient and the doctor ample time for proper treatment or prevention. Also, there are few infant-specific wearable devices such as OLED sock, temp track, which are being used by parents to monitor oxygen level, heartbeat, temperature, etc. All these wearable devices are providing the user an opportunity to manage, diagnose, and monitor their health, which is very crucial to have in the current day and time. Now moving on towards our next category, which is ingestible sensors. Ingestible sensor, also known as digital pill. This is a sensor which a user takes as a pill. The sensor sends the signal to a wearable patch which further sends the data to an application, as we can see in the images. This sensor is used to keep track of medication in some specific cases like bipolar disorder patients whose medication is time bounded. Moving on towards our next category, that is IoT enabled inhalers. These are smart inhalers which have an equipment attached to the inhaler which tracks time of the medicine taken. A smart device manages the data sent by the equipment. The device sends the alert to the asthma patient when required as per the target setup. This timely enforcement of medicine is helpful in eliminating the disease from the root. Our last category in current implementation is blind assistance. The blind assistance system helps blind or low vision people to become independent. A camera fitted glass is worn by any low vision or blind person. This glass captures all the details of the environment and sends them to a professional agent's dashboard. These agents assist the user with their surroundings and directions using an earpiece providing live assistance. Currently, the setup is little costly, but with time and continuous growth in technology, the system can be affordable and will help many lives all around the world. This is the current state of IT in healthcare, and it truly has a lot more to offer, which will be discussed under Future of IT in Healthcare by my project mate Punj Prakash. Thank you for your time.
Let's talk about the future of IoT in healthcare and what will be the benefits of this technology. Future of healthcare will be more proactive rather than reactive with the help of IoT, big data and artificial intelligence. Most of the current health IoT devices are wearable. What comes after wearable? That will be insideable. Healthcare IoT devices in future will be wearable and also insideable. What is insideable? It is a microscopic device that can be implanted in the human body to perform diagnostic tasks and monitor bodily functions 24 into 7. Let's look at the figure 1 to understand high-level architecture design of integration among sensors, cloud computing and GUI. As you can see in the figure 1, all our IoT devices or sensors will be connected to IoT cloud computing platform, which will provide meaningful information of all the data with the help of big data and AI to the end client, which can be mobile or any stationary devices connected to the internet. Now let's talk about the benefit of IoT in future healthcare. First and foremost benefit that I can think of is predictive and preventive healthcare. With the help of IoT devices, real-time health data of patients will be gathered efficiently. Such devices will be able to send data seamlessly to cloud for analysis. With the help of data analytic techniques and artificial intelligence, we will able to predict the possibility of any disease occurrence and preventive care can be taken against the disease. Another benefit is control epidemic. As the data is gathered and shared seamlessly, any sign of possible epidemics can be early detected, and preventive measures can be taken to avoid outbreak of a disease or to retain it within an area or in a community. In USA, about 3% of critically ill patients are responsible of 65% of healthcare spending. One of the main reasons of this spending is hospitalization and expensive health monitoring machines. In future, IoT device will able to provide most of the health monitoring data and also able to share real-time data seamlessly to hospitals. The doctors and data analytics driven software will able to send out alert messages to take necessary steps ahead of time. Another very important benefit we can think of is making healthcare more accessible. One of the biggest benefits will be accessibility of the healthcare. With a limited medical care workforce and about 7 billion world's population, the IoT devices will be able to monitor the health of people living in rural areas or people in poor nations that have where even fewer people in healthcare. Another benefit is eliminating manual data entry and errors. Since the data will be generated in real-time manner through IoT devices, this will eliminate the possibility of data entry errors and wrong diagnosis of the individual. It will also give better disease management as the medical history of patient along with the patient vitals will be seamlessly shared with the physician and hospitals via EMR, which is electronic medical records. The probability of managing the disease efficiently will also increase. Last but not the least, it will enhance the patient experience. Remote and real-time patient monitoring means fewer visits to the doctor and the hospitals. Continuous observation also ensures early illness detection. Data-driven healthcare decisions will be more accurate. We can expect fewer errors and misdiagnoses, and thus a reduction in resource, time, and money wastage. All this indicates a vastly improved experience for the patient. So these are the few benefits of IoT in healthcare. Now we'll talk about challenges in implementing IoT in future healthcare.
Hi everyone, my name is Ashutosh Shukla. Moving on to challenges. The key challenges that we have with IoT in healthcare are security and privacy, technology errors, regulating technology, changing market expectations, and scalable communication connectivity. Starting with security and privacy. So here sensitive HIPAA data is involved, which is a personal healthcare and medical data. That data is with our hospitals, employers, labs, physician, and with us. So with IoT in healthcare, the data will flow through IoT devices. And if cyber attackers are able to get hold of that data, they may try to blackmail us. They can even try to do medical identity theft and try to buy some restricted drug. They can even try fraud insurance claim. So all that is very dangerous. So also to add to all that, currently there is a lack of proven antiviruses in IoT domain, especially in healthcare. So with the number of IoT devices increasing in healthcare, this risk is constantly increasing. So there is a need of getting better antiviruses. Also, some medical conclusions can be derived by corporates which access our personal data, and they may try to offer you some products that you may not like. Next challenge, technology errors. So the IoT devices in healthcare domain interact with human body directly or indirectly. So if there is a technology error in them, that can cause some damage to human body, and it can even cause death. So that's very dangerous. Also, when that happens, that becomes a huge financial liability for hospitals and insurers, which is also a concern. Also, on like not very serious stuff, like if some insurer gave you some tracking device to give you some incentives and discounts if your health or activity is showing better. So if some wrong data is reported, then insurer will give you more incentive, which is a financial loss for the insurer. Also, the IoT hardware components are also very important. So when there is a technology error, so the hardware component need to ensure that it takes a safer route in case of confusions and failures and cyber attacks, and not harm human body in any case. Next challenge, regulating the technology. So the IoT devices will access data across various countries. So now the healthcare laws vary across countries, so there is a confusion on how if there is an issue, how that will be resolved. So there is a need for all the countries to come together to decide on the common laws that all countries will follow with IoT in healthcare, and they cooperate with each other. So once those final laws come up, then the big corporates will be motivated to invest more in IoT with healthcare. Next is constantly changing market expectations. So the customer is ready to try new products in healthcare field with IoT. So IoT technology in healthcare is definitely here to stay, but the key players will keep changing. So a huge investment may fail if a robust, stable, scalable product is not delivered. So we need to ensure, the inventors need to ensure that they deliver a quality product when they are doing huge investments. Also, the inventors which are constantly working on creating IoT devices which to help human health are not getting enough support from government and community. So they should get more support. Next is scalable communication connectivity. So currently, these IoT devices are doing a client server model. All the IoT devices send data to the server. So that doesn't seem feasible when the number of IoT devices will increase drastically. So at that point of time, there is a need of a peer-to-peer communication. The IoT devices should interact with each other, and only consolidated data should go server. Then only it will be a success. Coming to conclusion at the end, the key conclusions that we can derive are: IoT will certainly revolutionize our future positively. That's true. IoT, along with the big data AI, will make healthcare simple, affordable, efficient, and accessible for everyone. So that is certainly going to happen. The only thing is that we need to overcome the challenges like privacy, security, and the bodily injury thing that we talked about to ensure that all this is success. Also, data collected by IoT devices will facilitate more predictive and preventive healthcare to help humans. Okay, so that's the end of the presentation. Thanks everybody.